Hey, Garrett.
Hey, Miss Sparks.
How are you?
I'm good.
Good. Do you want to work on this together, or do you just have specific questions, or what?
I just have to go through the worksheet.
Okay. All right.
But I've already done 22 and 23, so I don't need to do that.
Okay. All right. Praise the Lord. All right. Well, let's start on the simplifying the rational expressions at the top. And the first thing that you want to do is factor. And when it comes to simplifying, multiplying, and dividing, you always want to just factor first that numerator and denominator, okay? So we can look at that numerator and see that you could factor out a 6x out of both of the terms, the 12x squared and the 30x. And you also really want to be thinking about these in terms of you don't want to cancel on top of each other. Those are actual, like almost like factors. So that's going to factor out to be 6x, and then 6x goes into 12x squared with 2x left, or you can factor that 6x out of 12x squared and get a 2x, and then factor out a 6x out of the 30x, and you're going to get 5. And then on the bottom, looks like we can factor out a 10x squared. And then we would be left with 2x minus 5. So now let's simplify what we can. You know, you can factor that, you can cancel the 2x minus 5 out. And we've got a 6x over 10x squared. So this 2 goes into both 6 and 10. So that leaves us 3 over 5. And then we've got 1. This is an understood 1. So 1 minus 2 using our exponent rules. So that's going to leave an x at the bottom. So 3 over 5x is our final solution. Sorry, I needed to finish typing something real quick. Okay. Does that make sense?
Yeah, it does.
Okay. All right. So now for number 2, looks like we can factor out a 4 out of the top. And that's going to leave us with a squared minus 9. And we can factor out an 8 at the bottom here. And that's going to leave us with 3 minus a. And at the top, that a squared minus 9, we should notice right away that that's the difference of 2 squares, which can be further factored as 4 times a plus 3 and then a minus 3 all over 8 times 3 minus a. And now this 3 minus a with this a minus 3, we need to start recognizing that as a negative 1. That factors to be a negative 1. We also can see that this 4 will factor out here, leaving 1 at the top and 2 at the bottom. So now we have at the top 1 times a plus 3 times a negative 1. So that's going to be a negative a plus 3 over 2. So that can be, I don't know how Miss Wynn has y'all doing it. Does she let you leave it like that, or does she want you to go ahead and put that negative all the way through, writing it like this?
I'm not completely certain, but I don't remember her making us do that.
Okay. All right. Well, what I would do is just know that it's both ways, and maybe clarify with her tomorrow in class which way she prefers it, if she has a preference. I would just
technically both the same thing.
Yeah, they are really the same thing, but I don't some teachers want you to work it completely out. But I'm happy with leaving in factored form just because it shows me that you know that this weird thing right here, this and this factor to be -1. And that's a really, really important thing to remember, just like remembering that this is the difference of two squares. So, but just as a point of clarification with her tomorrow, I would ask.
Okay.
And then this last one, at the end here, we want to find two factors that multiply together to give us a positive 40 that when we combine them, give us a negative 13n. That's going to be n minus 8 and n minus 5. At the bottom, a little bit of my side work, which I might then erase, but just letting you know this is side work. You're going to either slide and divide or do the AC method. So that's 3 times a negative 5 is a negative 15. So that's 3n squared. I'm looking for two factors that multiply, that give me a negative 15, that when I combine them, give me a negative 14. So that's going to be a negative 15n and a positive 1n. And then I want to factor by grouping. Looks like I can take a 3n out. And basically this is an understood 1 out front. So then I know that my factors up here are going to be 3n plus 1 n minus 5. So I can cancel the n minus 5s. So my final answer is n minus 8 all over 3n plus 1. And I usually try to keep my factors in parentheses. You don't have to, but it's just nice to know that they're factors. Square up my answers. Okay, any questions about those? And how do you feel about that?
I feel really good about that.
Okay, cool. All right, number 4. I've worked this a few times. The factoring on it definitely, I mean, it's got some factoring. Let's put it that way. So what I'm probably going to do here, Garrett, is just do the side work and then erase it once I get my factor. Is that okay with you?
Mm-hmm.
Like I'm going to take the 6p squared minus 13p plus 5. And I'm looking for two factors that multiply together to give me a positive 30, while at the same time giving me a negative 13p when I combine them. So I'm thinking negative 10 and negative 3. $6p minus 10p minus 3p plus 5. So I'm going to group. So I know that I can take out a 2, and that's going to leave me with 3p minus 5. And over here, I'm going to take out a negative 1 because I want this coefficient, that negative 3, off. So negative 1, and then that's going to leave me 3p plus 5. Oh, I'm sorry. This was supposed to be a p. Sorry about that. So my factoring for the top of the numerator in the first fraction is 2p minus 1 times 3p minus 5. That's the top one. Am I okay to erase?
Yeah.
Okay. And now I'm going to factor the bottom one. As I recall, I can't remember some of the other factoring in the worksheet. I just remember this being loads of fun. Definitely, you know, steps up the factoring challenge. All right. So we're looking for two factors that multiply together to give you a negative 18, that when you combine them, give you a positive 17. So that's going to be positive 18 and negative 1. So you have 2p squared plus 18 minus 1 minus 9. Then we'll start grouping. I can factor a 2p out. Factor out that negative here. Didn't leave myself much space to do that. Changes the sign of everything in there. So I have a 2p minus 1 and a p plus 9 for the numerator. So that's my factoring for that one. So now factoring p squared plus 16p plus 63. I'm looking for two factors that multiply together to give me a 63 that when I add them will give me a positive 16p. So I'm thinking 9 and 7. So that's going to be p plus 9 and p plus 7. Because 9 and 7 multiply to give me 63, and when I add them, they give me 16. And the numerator or the denominator in this one, I can factor out a 4. And that's going to leave me p plus 7. So now I'm looking for things that I can cancel either vertically, up and down, or diagonally. And I see vertically, I can cancel the 2p minus 1. I see diagonally this way, the p plus 9. And I see vertically here, the p plus 7. So now I want to go back and see, what do I have left over? Well, I've got a 3p minus 5 on the top. And I've got a 4 on the bottom. And I can't see anything else that cancels, so that's my final answer for that one. Any questions about that? Feel pretty good?
Mm-hmm.
All right, so on number 5, we want to factor that numerator. So it looks like automatically we can factor a 2 out of that. We get 25 minus w squared. And then looks like on the bottom, we can factor out a 3. That's going to be w squared plus 3w minus 10. And then the factors, I'm looking for two factors that multiply together to give me a negative 14. So that's with a positive 5 when I combine them. So I'm thinking 7 and 2, and one has to be negative and one has to be positive. And since this is positive, the larger of the two has to be positive. Does that make sense to you?
Yes.
Okay, great. And then at the bottom, I can factor out a 6, and that's going to give me w minus 5. And over here, negative 10. Okay, over here, actually, this is the difference of two squares, which looks like this. And it's written backwards this time because it looks, because this, most of the time we're used to seeing w squared minus 25. But this one is going to look like this. Your two different signs are in the middle, but we've kind of flip-flopped our numbers. That's a little unusual. We don't typically see it like that. But that, a lot of times when I see that, I automatically know somewhere in here I'm probably going to have that -1 thing. Are you starting to recognize that pattern?
Yeah.
A little bit? Okay. So now for the numerator, we're looking for two factors that multiply together to give you a -10 that when I combine them, give me a +3. That's going to be 5 and 2. And the 5 is going to be the bigger of them. And then I'm just going to go ahead and rewrite this. I've got this one completely factored over here, nothing else. So now what we want to do is look for those things that we can cancel, simplify before you multiply, cancel either diagonally or vertically. And so I see W plus 5 and 5 plus W are the same thing because addition property is associative. So we can cross those two out. Diagonally, I see W minus 2 over here and W minus 2 over there. And here's that -1 thing where we have W minus 5 here and 5 minus W there. So I want to make sure that I write that -1 over here. The other thing I see is 2 will go into 6. So now I have a, what do I have left on top? I have a -1. And I have a W plus 7. And on the bottom, I have a 3 and a 3. So -1 times W plus 7 is on the top. That's all over 9. And that could be written like this. Either way. All right. On the division, you're going to keep flip change. So while I'm doing that, I'm going to factor if at all possible. And I see on that first one, I can factor out a 5. And I'm going to change this to multiplication. And I'm going to put this on top, but I'm going to factor it. And I know I can factor an 8 out. So 8, and 8y more specifically. And that's going to leave me with 5y minus 4. All over. And then 25y minus 20. I can factor out a 5. And that's going to leave me y minus 4. Is that right? No. 5y minus 4. So let's see. Vertically, I can cancel these. Diagonally, I can cancel that. 2 goes into 8 4 times. So I have a y plus 1 left, a 4 left, and a y left at the top, and nothing at the bottom. Because everything canceled at the bottom. So my final answer is 4y times y plus 1. Okay. Number 7. The numerator there, I can factor out a 2. That's going to leave me c squared plus 2c minus 3. And at the bottom, I'm going to do my side work on that because I can already see I need to use the AC method on that. So here's my side work for that. Two factors that multiply to give me a positive 12. That when I combine them, give me a negative 7. That's going to be my negative 4, negative 3. So 4c squared minus 4c minus 3c plus 3. I'm going to group them. I can factor out a 4c. Factor out a negative 1. Whoops. So my factors are 4c hang on, I'm just looking at something real quick. Oh, I'm sorry. This is supposed to be a 3. I was like, what did I knew I did something wrong. 4c minus 3 times c minus 1. Did you follow that even though with my error?
Yeah.
Okay. All right. Am I okay to erase the side work on that?
Yes.
Okay. Let's see. And then we'll change the division to multiplication. And we'll flip that or change that last fraction into its reciprocal. So change to multiplication. And while I'm doing that, I'm going to go ahead and factor. Oh, actually, I can take a look at this. And this may not be recognizable right off the bat, but this is also the difference of two squares because that 16c squared is a perfect square and 9 is a perfect square. And we've got that minus sign in the middle. So the difference of two perfect squares. So that factors to be 4c minus 3 and 4c plus 3, just like any other difference of two squares. Maybe not recognizable right away, but it's one of those things where you really kind of have to be thinking about 1, 4, 9, 16, 25, all as perfect squares, and just kind of be on the lookout for those. Okay?
Mm-hmm.
And then on the top, we can factor out a 16c, and that's going to leave us with c plus 3. And this top here factors to be c plus 3, c minus 1. because we were looking for two factors that give me a -3 that when I combine them give me a +2. So on the top, let's see, we can vertically, we can cancel the c plus 3 with this c plus 3. We can, that was diagonally, I apologize. Vertically, we can cancel the c minus 1 and the c minus 1. Diagonally, we can cancel the 4c minus 3 with the 4c minus 3. And then we've got this 2, which cancels with the 16 and leaves us 8 at the bottom. So on the top, what we have left is 4c plus 3. And at the bottom, we have 8c. So 4c plus 3 at the top and 8c at the bottom. Did you get all that? Am I moving the screen too quickly?
Hold on, let me look at it real quick.
All right, hold on.
Yeah, I got it.
You did?
Yeah.
Okay. Okay. Number 8. Looks like we're subtracting. So what we want to do is check to make sure that we have the same denominator or common denominator. And in fact, we do. So all we have to do is really subtract everything. But a word of caution, since it's subtraction, this technically is being distributed to the x minus 20. So that means that's going to be minus x and then plus 20 all over x squared minus 16. So this then becomes 5x plus 20 all over, and we're going to go ahead and factor that. That's going to be x plus 4, x minus 4. And now we can factor the top, and that we can factor a 5 out, and that becomes x plus 4. So x plus 4, x minus 4. And then we don't cancel until the very last step in addition and subtraction. Okay? So then we got it to here, and then we factored the numerator, because then you factor and then you cancel.
It's basically once you get rid of all the addition and subtraction, and it's just multiplication.
Once you get done with everything. Yes. Once you get done with everything. But it's like the very final steps. At the very front, you don't want to do anything. I didn't even really start factoring till the end. And the only time that you would want to factor the denominator at the beginning is when the denominators aren't common. But you'll notice I didn't start factoring the denominator even until I'd done all my combining when they're common. Does that make sense?
Yeah.
Okay, good. All right. So now they're not common in number 9. So I have to get a common denominator. So this is what I'm going to do. I'm going to go ahead and factor this one. And I can factor a 3 out. Okay. And so that's this factored. And so this one is missing, this first one is missing something. It's missing that k plus 5 to be the same, right? Yeah. So in order to get a common denominator, I have to multiply the top and the bottom by that k plus 5. Okay? And
but you
then
don't have to multiply the other side by anything because it already has everything.
Perfect. Yes, that's absolutely correct. Good job. Good job. And I just go ahead and leave the denominator in factored form. But now I have to distribute this 16k to everything in here. Okay? So that's going to be 16k plus, let's see, 16 times 5 is 80. And now this subtraction gets sent to everything over here. So that's going to be minus 4K minus 56. All over 3 times K plus 5. Okay?
Mm-hmm.
All right, so now we're going to combine like terms. So that's 16K minus 4K. So that's going to be 12K. And then 80 minus 56 is plus
24.
14. What is it? 24?
Wait, 80 minus 56 is 24.
Yeah. 24. Okay. All right. All right. All over 3 times K plus 5. So I can factor out a 12 at the top. And then that changes to a 4. So then my final answer is, I'm going to write it in green because it's all cattywampus. Sorry about that. K plus 2 over K plus 5. Can you see that?
Yeah.
Okay, there. I'll scoot it up a little. Does that help?
Yeah.
All right. Is this making sense to you?
Yes, it does.
Okay, great. Stop me. And I love how you're interjecting and saying, making clarification points. I really appreciate that because that really helps me know that, that all this is working. Yay. All right. So the first thing, we know this is addition. So we want to factor the denominator to find out what's missing. Not really worried about the numerator at all, but we do want to factor the denominator, find out what is missing from each of them. So we're looking for two factors that multiply together to give us a positive 9, but when we combine them, give us a negative 10. So that's going to be m minus 9, m minus 1. So right away, that first fraction isn't missing anything, but we can see that this second fraction is missing the m minus 9. So we're going to multiply the top and the bottom of it by m minus 9. So our next step is going to be m squared minus 7m minus 18. This is a plus. So we're really distributing a 6, a positive 6 to both things inside the parentheses. So positive 6 times m is positive 6m, and a positive 6 times a negative 9 is a negative 54. So we've got this big old thing all over m minus 9. And once again, I leave the denominator in its factored form, just in case on that last step I can factor anything out. I'm going to combine like terms. There's no other m squared, so I need to write that down. I've got a negative 7m and a positive 6m, so that's going to be a negative m. And then I've got a negative 18 and a negative 54, so that's a negative 72. All over m minus n, 9, sorry, m minus 1. So I'm looking for two factors, excuse me, that multiply together to give a negative 72 that when I combine them, give me a negative 1. Those factors are a negative 9 and a positive 8. So now what I want to do is find things that I can cancel because I'm at this very end step. And this is where we factor and cancel at the very end of addition and subtraction. And that we have vertically an m minus 9 and an m minus 9. So my final answer is m plus 8. Instead of rewriting it, I'm just going to circle it or like that, okay? M plus 8 over m minus 1. That's our final answer. All right. On this next one, once again, we want to go ahead and factor that denominators, but the denominators only because we're just looking for what's missing, if anything, in order to get a common denominator so we can add the expressions. So I'm going to factor, and I want to point out that this, once again, is the difference of two squares because 4r squared and 1 are both perfect squares. So 2r minus 1, 2r plus 1 is this in factored form. So I look back over at that first rational expression, and I notice that it's missing the 2r minus 1. So I'm going to multiply the top and the bottom by 2r minus 1. I don't have to do anything, like you pointed out earlier, to the second one because it already has everything. But I am going to write it in factored form if I have room. Okay, now I'm going to distribute this r and combine like terms. So r times 2r is 2r squared, and r times negative 1 is minus r. And then I'm going to distribute. This is like saying a positive 12r minus 6 all over 2r plus 1, 2r, minus 1. Combine like terms where I can. Nothing to combine with the r squared, so it's 2r squared. Then I've got a minus r and a plus 12r. So that's going to be plus 11r minus 6 all over 2r plus 1, 2r minus 1. So now I've got to factor the numerator. I'm at that final step. I've done everything. I've multiplied where I needed to and distributed everything. So now I'm at the final steps and I can factor that top one. So I'm looking for, basically it's going to look, I'm going to see if I can write it small enough. This is my side work way up at the top. Can you see that okay?
Yeah.
So I'm looking for two factors that give me a negative 12 that when I add them, give me a positive 11. So that's going to be a positive 12 and a negative 1. So 2r, I'm hardly going to have enough room to do it on here, squared plus 12r minus r minus 6. Then group them. Can you see that okay? 2r.
Yeah, I can see it.
Great. Bless you. You're so kind. Plus 6. And then negative 1. And then r plus 6. So our factors are going to be 2r minus 1. And then r plus 6. All over 2r minus 1, 2r plus 1. So we can see the 2r minus 1, those cancel. And then r plus 6 over 2r plus 1 is our final answer. So you see how we factored the denominator only at first to get the common denominator. And then we do all of our, multiplying to make sure that, we're by getting the common denominator, you have to multiply that top. Then we distribute things, then we combine like terms. And then that final step is where we factor and simplify the numerator and denominator. Is that making sense? Kind of the steps, the procedure you'll take?
Yeah.
Okay, good. Because I know that, a lot of times you get into this rhythm and this pattern of simplifying and when you do the multiplying and dividing. And so you kind of have to switch gears a little bit. All right. The common denominator for number 12. We know that there is an 8 and a 3 here, and this is 8 times a. So this first one we need a 3 for, a 3 to multiply. So we're going to do a plus 4 and we got 8a, and then we're going to multiply the top and the bottom by 3. Plus, and then over here, we're missing an a. So we'll multiply the top and the bottom by a. Does that make sense? So now we have a common denominator of 24a. And then we'll just, did that make sense to you?
Yeah.
Oh, okay, good. And now we're going to distribute that 3 to everything in the parentheses. That's going to be 3a plus 12 plus, and then this is 5a. And now we'll combine like terms. 8a plus 12 over 24. A 4 will come out at the top. A. That was messy. 2a plus 3 all over 24a. And so my final answer is 2a plus 3 all over 6a. Okay, on number 13, understanding that both of these are factors. The first one is missing h plus 5, and the second one is missing h plus 2. So you're going to have to multiply everything at the top of the first one by h plus 5, and the bottom as well. And the second one, you're going to have to multiply the top and the bottom by h plus 2. In order to get a common denominator. This, by multiplying the top and the bottom, you're not changing the value. So I'm going to distribute the 2. That's 2h plus 10. And then I'm going to distribute the 5 plus 5h plus 10. So then we combine like terms. And that's going to be 7h plus 20 all over h plus 5, h plus 2. And believe it or not, as beautiful as that is our final answer for that one. So that's kind of nice, isn't it?
Mm-hmm.
All right. This next one, I worked this earlier, and it's kind of involved. So I'm glad they gave us some room. And I'm also
do like the subtraction part first, and then add that to the addition part.
Yes, you kind of do that. That's really good. I'm glad that you saw that. Basically, what we're going to end up doing is getting a common denominator all the way across, and then just using this right here, the subtraction, almost like multiplying everything through here by a -1. Okay? And I'll show you that in just a minute. But what we want to do first off is factor x squared minus 4x plus 3. We're looking for factors that multiply together to give you a +3. So that's going to be 3 and 1. And then when you combine them, give you a -4. So that means both of them have to be negative. So that's a -3 and a -1, which then indicates that this and this are all factors of that third denominator, but each one is missing something. So what we're going to do is multiply that first one by what is it missing in the denominator? What is this one missing?
It's missing the x minus 3 part.
Perfect. So we'll multiply the top and the bottom by that. And then that second one, x minus 1, it's missing the x minus 1 part. Okay? And then this final one isn't missing anything at all. But I'm going to write it in factored form. Okay, so now we have to FOIL these. So when you FOIL 3x minus 1, we've got 3x. You do first, outside, inside, last. So first is 3x times x. So that's going to be 3x squared. And then outside is 3x times -3. So that's going to be -9x. And then inside is -x times x. So that's -x. And then last is -1 times -3. So that's going to be a +3. Now, this one, I'm going to put the minus here, okay, for this minus right here. But I'm going to FOIL this. And when I do, I'm still going to put it in parentheses because this minus has to apply. It's a special minus. It has to apply to everything once I've FOILed x minus 1 times x minus 1. And I know that to be a perfect square. So that's going to be x squared minus 2x plus 1. And then I'm going to add x plus 1. And that's all over x minus 3 times x minus 1. Okay. This minus gets applied to this. And then when I take the minus to this, it changes that to a positive. And when I take the minus to this, it's now a minus. Does that make sense to you?
Yeah.
Okay, good. So then I'm just going to take my brackets off. And now I have 3x squared minus x squared. So I haven't really left myself enough room, but I'm going to, which is going to be 2x squared. So I got rid of those. And then I've got a minus 9x minus x. That's going to be minus 10x. Minus 10x plus 2x will give me a minus 8x plus x. That's going to be a minus 7x. Okay. And now I've got a plus 3 minus 1. So that's going to be 2 plus 1 is 3. All over x minus 3, x minus 1. Are you seeing where we got everything?
Yeah.
Okay. All right. Now we'll factor, and I'm going to borrow this down here, this space, to factor the 2x squared, and then I'll erase it. But can you see it okay? Can you see it?
Yeah, I can see it.
Okay. So that's going to be negative 6, negative 1. So 2x squared minus 6x minus x plus 3. And then I will group them. So I have 2x minus 1 times x minus 3 all over x minus 1, x minus 3. And the 2x minus 3's cancel. So my final answer is 2x minus 1 over x minus 1. That was a problem, wasn't it?
Yes.
I'm going to give you a big hint. If she plays the scavenger hunt game that I'm thinking about playing with my students, I have to double check and make sure everything's okay on it. That problem is in the scavenger hunt. So if she lets you keep your homework, you'll have the answer. Okay, number 15, complex fractions. Basically, it's just a division problem. So you'll keep the first one. And I'm going to go ahead and factor it. Two factors that multiply together to give me 45 that when I add them, give me 14. That's 9 and 5. And so on this, I'm going to flip it to its reciprocal because this is really a division symbol. So this is now going to be on the top. So I'm going to factor it while I'm doing it. So I'm looking for two factors that multiply together to give me a negative 18 that when I combine them, give me a positive 7. I'm thinking 9 and 2. And obviously the 9 needs to be the bigger one because we've got a positive 7. And then I can factor out a 3m squared out of this, and that's going to leave me m minus 2. All right. So let's take a look and see what we can cancel vertically and diagonally. Vertically, we can cancel the m minus 2. Diagonally, we can cancel the m plus 9. So what we've got left is 12m cubed. Oh yeah, we can actually factor this. We've got a 3m squared, and that actually goes into that with 4m left over. Because 12 over 3 is 4, and m cubed over m squared is just an m. So now we've got 4m on the top and m plus 5 on the bottom left. And that's my final answer. All right. For number 16, one of the things that we have to check when you have a complex fraction is you need to have a single fraction on the top and on the bottom. And we do have on the top, but we don't on the bottom. So the first thing that we want to do is we want to get that bottom fraction to be a single fraction instead of an addition problem. So we need to get a common denominator, which is going to be 6. We got to multiply that k by 2. Is that making sense to you where I got that? Mm-hmm. And then I multiply, because I'm basically I'm multiplying the top and the bottom of this one by 2 and this one by 3. So now on the top, I have 8k plus 12 on as my top fraction. And the bottom, I'm going to keep flip change. Let me show you what that looks like first. Because you want to combine like terms. That's going to be 2k plus 3 all over 6. So now I'm going to flip this. My 6 will be on the top, and my 2k plus 3 will be on the bottom. And this factors, I can take out a 4, and that becomes 2k plus 3. And now I can see that these cancel vertically. 3 goes into 6 2 times. 3 goes into 9 3 times. So I have a 4 and a 2 left on top. And 4 times 2 is 8. And I have a 3 on the bottom. All of that to get 8 over 3. Okay, on number 17 and 18. Both of those actually, once again, you need to get single fractions on the top and single fractions in the denominator, and neither on 17 or 18 do they have that. So we need to get a common denominator for the top, and that's actually going to be, we're going to multiply this by b, and we're going to multiply this by 2. So b times b is going to be b squared at the top. And 3 times 32 is 96. All over 2b. Is that right? No. I'm oops, stop. It's supposed to be 2. I can't read my own writing. This is a 2. So I was like, that can't be right, because I knew they were trying to go after the difference of 2 squares. So that's going to be 64. I just can't read my writing. I thought it was a 3. It helps if you can read your own writing. This needs a common denominator. This is really like 1 over 1. So this needs to be multiplied by b over b. So that's going to be b plus 8 at the top, all over b. So now we're going to keep flip change. We keep the top one, which we should note that that is the difference of 2 squares. So that's going to be b plus 8, b minus 8, all over 2b times, and now we're flipping this to multiplication. That's the times, and the b will go on the top, and the b plus 8 will go on the bottom. and we look for what we can cancel vertically and diagonally. Diagonally, the b plus 8 cancels. And your left, let's see. Oh, and then the b's cancel diagonally. And we're left with a 2 on the bottom and a b minus 8 on the top. So b minus 8 all over 2. Any questions?
No, actually, I understand that pretty well.
Good. All right. So once again, we're looking for a single fraction on the top in the denominator. And like I say, there isn't one. So over here, we've got x plus 1 and we've got an x. So I know I need to multiply the top. I need to multiply this one by x. And then this one by x plus 1. So, man, there's a delay in the internet. So it's looks wonky when I write. So that's going to be x squared, and then we're going to distribute this 4 to everything in the parentheses. So that's going to be plus 4x plus 4 all over x plus 1 times x. And then down here, this actually factors to be x plus 1, 3 times x plus 1. So this has both things. So only this side needs to be multiplied by x plus 1 down here. So at the top, we have 4x plus 7, and then you're going to distribute a negative 1 inside the parentheses. Minus x minus 1 all over 3 times x plus 1. And so this, oops. So then 4x minus x is going to be 3x. Thank you. And then, let's see, I think when I keep flip change, Garrett, I'm going to combine these. Does that make sense to you? Combine like terms when I keep flip change?
Yeah.
Or would you rather me just erase this and combine them? What would be easiest for you?
I think erasing them and combining them would be easier.
Okay. Okay, so 4x with this x here, negative x, is going to give me a 3x. And then the positive 7 with the negative 1 is going to give me a plus 6. So that's how that was done. Does that make sense?
Yeah.
Okay, good. All right, so I'm going to keep flip change. And remember, this is just a big old division sign. So the top, I'm gonna factor this one while I rewrite it. X squared plus 4x plus 4 is going to be x plus 2 times x plus 2 all over x times x plus 1. And then times, because we're changing this. Oh, I've really crowded myself here. 3 times x plus 1, because that's the denominator. And then I'm going to factor this 3x. I'm sorry, it really got bunched up. I don't know if you can follow that or not. Can you?
Yeah.
Okay, because that's the denominator on the top now. And then I factored this. So, wow, that's wonky looking. This cancels. The 3's cancel. The x plus 2 cancels with one of the x plus 2's. The x plus 1 here cancels with the x plus 1 diagonally over here. And that leaves us with x plus 2 over x as our final answer. That was crazy. I just didn't have enough space there. That would have taken me a whole piece of notebook paper.
Oh, just a heads up. I've already done 22 and 23.
Okay.
So
all right. And that's those two, right?
Yeah.
All right. So we're just going to go on to 24 and 25. Okay. So with these, you want to go ahead and factor the denominator, or factor all of them. Yeah, factor all the denominators. So p squared minus 7p plus 6 can be factored. Would be p minus 6, p minus 1. So what you want to do is multiply the whole thing by a common denominator. Well, p minus 6 and p minus 1 has everything, has this p minus 1. It doesn't have the 3. So it looks like the common denominator is going to be 3 times p minus 6, p minus 1. Okay? All three of those factors. Does that make sense to you?
Yes.
Okay. So when I look at this first rational expression, I see that it has p minus 6 and p minus 1. So they kind of essentially cancel. But I have to multiply. Everything that it's missing, I have to multiply the top by. So I'm going to multiply it by 3 because that's the only thing missing. Plus, this second piece is missing both the 3 and the p minus 6. So I got to multiply that by the 2. But everything else canceled. Oh, come on, Miss Sparks. I'm trying to keep the other number. All right. And on the end here, this 2, it has a 3 in the denominator. So it's going to have to be multiplied by p minus 6, p minus 1, and then the 2 was already there. Okay?
Mm-hmm.
So, but now, once I distribute all of these things, I actually have a linear expression. So I'm going to distribute the 3. So it's going to be 3p squared plus 3p plus 24. And now I'm going to multiply 3 times 2, which is 6, and distribute the 6 into the p minus 6. So that's going to be plus 6p minus 36, because 6 times negative 6 is negative 36, equals, and then I can already see from back up here that this foiled would be p squared minus 7p plus 6. So if I multiply that 2 to that, I'm going to have 2p squared minus 14p plus 12. All right. I'm just making sure that any questions about that?
No.
Okay. So now I have to combine all my like terms. Let's see. Over here, I have, I don't have any other p squareds on my left side. So I've got 3p squared, but I do have a 3p and a 6p. And I think that's it for those. So that's going to be plus 9p plus, and then I've got 24 minus 36. So that's going to be minus 12 equals, so I got all of that. 2p squared minus 14p plus 12. And now if I subtract 2p squared and I actually add the 14p and I subtract 12 from this side to get everything back over to here, I've got minus 2p here. So that's going to leave me with a p squared plus 14. I'm going to add the 14 to the 9. And that's going to give me a 23p. And I'm going to subtract 12 from 12. So I'm actually combining two negatives. So that's going to be negative 24. And that all cancels. So that's going to be equal to 0. And now I factor. And I'm looking for two factors that multiply together to give me a negative 24 that add to give me a positive 23. So that means one of my factors will be negative and one will be positive. The bigger one's going to be positive. So that's going to be p plus 24 and p minus 1. So my possibilities of answers would be p plus 24 equals 0, which is p equals negative 24, or p minus 1 equals 0, or p equals 1. This is where you have to go back to your original equation and see if I put either negative 24 in or a 1, would I get a 0 in the denominator anywhere? So you go back up here, and in fact, I would, right? Mm-hmm. If I put a 1 right here in this equation, I would get a 0 in the denominator. So this makes this what's called an extraneous solution. So the only solution to this problem is negative 24. And my brackets are ugly, but those are my brackets. So P equals negative 24. So you really have to double check those solutions to make sure you don't get an extraneous one. Am I okay to erase?
Yes.
Okay, so on that last one, oh, please, now my computer's locking up on me. On the last one, we want to, I'm going to make sure I get this side erased. Most important side, so I can work on 25. We want to factor the denominator in order to get a common one. It's taking me forever to erase this. Hey, Bill. Momo's calling me. Can you please call her and see what she wants? Thank you. Yeah, she's like blowing up my phone. All right. So we've got to factor the denominator in order to ensure we're getting a common denominator. So a 3 will factor out of this to leave me 4v plus 3. So we see that this side has both the 3 and the 4v plus 3. So if we multiply the whole thing by 3 times 4v plus 3, the first one is missing the 4v plus 3. The second one is missing the 3. And then the one on the right side of the equal sign, it's not missing anything. So we're going to multiply 4v plus 3 times 1. here. Minus, and then this second one is missing the 3. So we'll have to multiply the top. Or this, technically, it cancels, so you're actually multiplying that. That's kind of what you're doing. And then you got v squared minus 3v minus 18. Okay? Does that make sense?
Yeah.
Okay. 4v, okay, plus 3 minus 3. So those cancel. And then I've got to subtract 4v from this side and bring it over here. To get a 0 on that side. So now I have v squared minus 7v minus 18. And so I'm going to factor this. I'm looking for 2 factors that multiply together to give me a negative 18. When I add them, give me a negative 7. So that's going to be v minus 9 and v plus 2. So I set each factor equal to 0. So my possible answers are negative 2 or positive 9. But I want to check for extraneous solutions. And if I plug either of them back in, I can see that I'm not going to get a 0 in the denominator. And that's what tells you if the solution is extraneous or not. So both 9 and negative 2 are possible answers. So that's your final answer for those.
Okay, we got that.
All right. Any questions?
No, not really.
Okay. Nothing about like extraneous solutions. You understand that really basically the only thing that makes it extraneous is if you get a 0 in the denominator.
Yeah.
Later on too, if you get a negative square root, that's also extraneous too. Things that aren't allowed in math, basically, or an imaginary number. But I don't think there's anything like that that's going to come up here. Predominantly, it's just going to be 0 in the denominator. And how are you feeling about factoring? Is it coming a little easier to you now that we're doing it literally all the time?
Definitely.
Yeah, good. And recognizing, big things to recognize are the difference of 2 squares, and when you have like a p minus 6 and 6 minus p, so that's that negative 1. Just those are just some things to just kind of keep at the top of your mind. But you can email me or Miss Wynn if you have any questions, okay? And I'll have Math Lab again on Thursday before the test on Friday.
Okay.
All right.
Thanks so much for Sparks.
No problem. Have a blessed evening.
You too.
All right. Bye-bye.